I believe so.
It's just on the it's on the Moodle page. So yeah, I thought it was a really good resource actually. No, even I learned quite a lot as well. It was good.
Yeah, and I think last semester the students had much more CAD instruction than before. So in many ways, they'll be more proficient than any of the previous years.
Yeah.
For different reasons. So okay, well that's fine. Let's just see how today goes. So good morning to all. I'll just keep admitting a few as we come through.
Would you be able to click record just before we start this?
Yeah, that's fine. So what I'll do today, this is really for you to ask me questions. If you'd like to raise your hand, then I'll ask you to put your question to me, then I can give an answer. As you've already heard, Sam and I were just talking about perhaps other things around CAD that we could put on Moodle for you, should you need to. But I would imagine that you're quite proficient. I know there was one question about using Fusion or Inventor. As far as I'm concerned, when it comes to the submission, as long as we see CAD drawings, we're not worried about how you create them or what software you create them in. I mean, it's completely up to you. The power and control, like, of really all the submissions, how you actually get to the point of creating the drawings and developing your concept, that's all for you to do. That's all in your control, always up to the group. So feel free to use whatever you're most comfortable with. But obviously, with the much more intensive CAD teaching in semester one, I would expect that Inventor, perhaps even Auto, I think you use AutoCAD as well for the 2D stuff. And then you would have had experience of 3D as well. So I don't mind which one you use. I mean, clearly for the 3D model that I've asked you to put forward, you would be using either Inventor or Fusion 360. But for the part drawings, general assembly drawings, it's up to you. But I suspect it makes a lot of sense to keep in one piece of software, and the ability to do everything in Inventor or Fusion 360 probably makes sense to stay with that. But like I say, the choice is yours. You're not going to be judged on, or we're not going to check to see which software you actually use to create the drawing. So don't worry about that at all. So let's have I'm pretty certain we're up to date with all the Moodle, the forum questions. So is there a question that you'd like to ask? And if so, if you please raise your hand, I will see it on the Zoom list, and then I can ask you. Okay, I can't see any hands raised.
How do we raise our hand? Is one question being asked.
There's a, in one of the function bars, let's have a look, you've got an option to raise your hand. I think they did this before Easter. We were doing this before Easter, so
yeah, I don't have it in reactions actually. So what, I'm just going to put a little clap.
If you keep an eye on the chat then, Sam.
Yeah, no problem. Oh yeah, of course. It's in participants for me as well. So there you go. I've raised my hand. So, yeah.
Oh, we have one here. Here we go. So Tomi Oni. Yeah, if you'd like to ask your question.
I just wanted to ask, what can we do if we have an absentee member that still isn't contributing work or showing up to meetings?
Okay, so what you'll do is, obviously you keep proceeding through the phases, right? You don't stop. and wait. And what I would suggest is that if you keep a record or a log of the emails that you've sent to the group, which will obviously include the absent member, then at the time of hand-in, if you email that to me, I can then make a judgment and then contact the student with regard to just finding out why there was non-attendance or non-contribution, because it might be that I'll have to adjust the group mark. There is 20% of the mark is for the concept drawing. So if that's not included in the report hand-in, so that will be lost instantly. It's one of those things where there are different mechanisms for dealing with this. It doesn't necessarily prevent people from not attending, and obviously the perspective I will have as Director of Studies means that I can see the whole gamut of reasons why students might not attend, and in some cases it's not that they are specifically not contributing to the group project. It might be that they are struggling across the board, perhaps with the environment of COVID and remote study. So there are other things that go on, but I can see all of that, and then I can take that into consideration. But the key thing for the group is that you keep proceeding through, and then you submit the report according to the format that I prescribed. If you have a better format, then that's absolutely fine. I have no problem with that. And then, like I say, you'll have the email sent, you'll have email replies. So if they do start engaging in the latter weeks, then at least you've got a record of when that is. So if you just cut and paste those into a separate document, email that to me, then I can deal with that separately. Does that make sense, Tommy?
Yeah, thank you.
Okay, good. So we've now got Michael Chu. Would you like to ask your question?
Hi. I guess just some stupid question about the CAD files and stuff like that.
Not stupid.
So is it so for each separate part, is it one 3D drawing file and then a whole set of orthographic projections for that part? And then I need to repeat that for, well, as many separate parts as I have in the table tennis ball launcher. Is that the case?
Yeah, so if I've...
Sorry, can I just interrupt? Can you turn the waiting room off, Rod? Because there's people waiting to get in. Would you be able to turn that function off so people can just join?
I've got 2 people waiting. Let me... I can... There we go. I think everyone's in now, Sam. I'll keep an eye on that.
Okay.
Just, I've turned that
Oh,
off.
is this recorded? Oh, well.
Right, so that's okay. Yeah, so right, so what I'll do is I'll explain it as I'll just give a general overview of this, because I think that'll be useful to all groups. So what you're being asked to do is you'll produce your assembly, and in your assembly you're going to have a series of parts. So let's just say you're going to have something down to, I don't know, let's say 20 parts.
Yeah.
Now, some of those parts you're going to buy out. So let's say, let's say the last one is the motor. Sorry, the first one is the motor. You're going to have that. And you'll have a part number. It's up to you what you call it, but I'm just going to keep with UoB. Say that's 001. Now, because you're not designing that part, you're just purchasing it. I would.
If I'm buying the part, I don't need to make any drawings for it. It's I kind of asked this question in terms of custom parts that we wouldn't be able to find anywhere else, like the 3D printing, laser cutting, etc., etc.
Yeah, exactly. So, but like I said, I'll just do it as a little overview so everyone understands exactly what's being asked. Now, because that's a bought out part, you don't need a separate part drawing. Okay, because you'll just purchase that using the Excel spreadsheet, you'll complete the Excel spreadsheet. We will purchase that part for you. We will know exactly what it is because you've put all the details in the ordering system. But let's say you're going to have, let's call it a chassis. A structure. Now that's going to still have a UoB drawing number, but you will have to have a separate part drawing because that's going to be your design.
Yeah.
Okay, so that's what the students will design themselves. You can't buy that completely as a finished product to your drawing. So you're going to have a part drawing. So even though, let's just say you are using a channel or angle. Let's say it's an angle. Now that angle you will you'll include in the UoB resource list the part number that we've put in for the angle, but you will have a drawing which will explicitly say where the holes have to be drilled, the length that it has to be cut to. So that must be a separate drawing. So let's just say that's the angle. So you will need to have this dimension on here anyway because we need to know what length that's going to be.
Yeah.
The height, if you like, and the details here, well that will come from the standard part or the part that you're purchasing from the University of Bath resource list. But you would still put that on the drawing so that we know what the part is. But the actual length that you cut it to, we won't know what that is. So that dimension has to be put on there as a separate drawing. It might be you've got a couple of holes. So you'll have some diameters, let's say that's 6. There's some diameters that you've got to include on here. You've also got to include the position of these holes. So you'll have dimensions on this angle. So even though you've bought that angle from our resource list, you'll definitely have to have a part drawing.
Yeah.
So, what you'll do is you'll go through all of the parts, and it might be that only half of them will need part drawings.
Yeah.
But we would expect a part drawing for everything that has some form of manufacture, even if it's just being cut to length. But I don't expect you to create part drawings for things that you would buy outside and you do nothing to. There's only ever been one exception in years gone by where I've said to the group, show that you can create part drawings by detailing up an external part, a bought out part, and that was because this was many years ago. There weren't many parts to the product, the assembly, and so they actually created a few drawings of motors and some other bits and pieces. But the project has changed quite a lot in recent years, so there's always a large number of parts, so there's always plenty to go around the group. And importantly, what we'll look for is an even distribution of these bespoke part drawings. You know, we don't want one person creating those. Those part drawings should be distributed throughout all 5 or 6 of you.
Right. So in your example, like that little sketch, so did you say that inverted L is a purchase part that gets embedded into one other part, so that it has to be drawn in or something?
Yeah, well, so here, if you...
Oh, no, not that one, the inverted L, sorry.
This one?
Yeah.
So this is the side view of the angle bracket.
Oh, okay. I didn't realize that the paper was the rectangle itself. I thought that was the chassis containing some random stuff.
Yeah, see, that's my bad planning, you see. So if I increase the size of the drawing sheet, let's say that's here. So yeah, yeah, that's the front view, that's the side view. You might need a plan view, but let's
Okay,
just say.
yeah.
But the important thing as well, you'll have a material requirement.
Mhm.
So don't forget to specify your material as well on your drawing sheet.
Oh, okay.
And then we'll see who's drawn it. So you'll have your name. The student name will be on the drawing sheet as well.
Yeah.
So you'll have that here. You'll have a part name, usual sort of things. So you complete that. So we can see additional bits of information.
Okay. So if it's a custom part, is the material just usually whatever is available from the 3D printer or something?
Yeah, so if it's a 3D printed part, I think you can just put PAL.
Oh, okay.
You can just put that as the material. Laser cutting is likely to be acrylic.
Yeah.
Your laser cut, 3D printing. I think I'll put this up on that's on the Moodle, and it's actually in the resource list as well. So, but then you might choose steel. You've got anything from our university list that you could choose from, plus anything from the approved suppliers, and they will give you material details there. So that information shouldn't trouble you. If you have any problems whatsoever, just email me, put it on Moodle, whatever, and we can sort that out.
Okay.
Really get stuck on that bit.
So as far as I understand, right now, for each custom part I have that I would have to, well, that my group would have to make for ourselves, there needs to be one part drawing in 3D and also an orthographic projection for it, right?
Right. Let me just take a step back. So what will happen is that you will have an assembly drawing.
Oh yeah, plus the assembly drawing. Yeah.
Yeah, you'll have an assembly drawing. I don't know what you'll do, but you'll have. It might be some wheels here. The ball feed might be coming down here, and these things are gonna rotate round at high speed and ping this thing out. So you'll have an assembly drawing of the whole thing, but this is in two parts, this assembly drawing, because what I've drawn now is the 3D view of it. And I think the most good thing is that this will be the 3D CAD drawing.
Yeah.
Okay, so you can print that off or include it in your report as a separate view on one page. Okay, and then what you'll have is your assembly drawing still, but you'll have your front view, might be the wheels here.
Like the orthographic projections, right?
Exactly, yeah.
Yeah.
That might be you'll have something like that, and then something like that. So that will be your chain splitter. And
yeah.
And the CAD exercise was a little truck this year. Did they actually get you to do a little truck?
No, not that I've heard of.
In the CAD lab. So what did you do in the CAD lab? What was the exercise there?
Which CAD lab? Like the like is it the do you mean the inventor exercises?
Yes.
Oh, a bunch of random stuff really. Well, at least for the first 6, and then there's a gas vessel, and then there's I think think a bottled drinks crate, I don't know, etc., etc.
So
Like-
in that set of exercises for Inventor,
Yeah.
did you have to do assembly drawings?
Not drawings specifically, but yeah, there were assemblies, and then we were also asked to basically project them orthographically. So
Okay, so in that case, let's assume they are assembly drawings, then you're repeating effectively what you did in those CAD exercises.
yeah.
To create those, as you call it, the three views of the assembly. You've got the 3D CAD, so that'd be quite nice to see a 3D version of what you've designed. I'll then have the assembly drawing, and then I will see part drawings of the bits that you've designed yourself.
Yeah, so
Yeah, and everything else will be known through the ordering system.
do I need to include the purchase parts in my assembly drawing? I assume I do.
Yeah, so absolutely everything that goes into your final product, whether it be, the batteries, little bearings, motor.
So in those cases, do I only need to make schematic representations of the purchase parts, or do I need to go into more trouble into I don't know, actually representing them completely?
Yeah, and this was my sort of final point really on it. They only have to be schematic, as you call it. Yeah, we don't need all the details, the curves and little reinforcing ribs, for the motor.
Yeah, wires, etc. Yeah, we don't need those, right?
Yeah, I mean, essentially, all the motors are going to be in a very simple.
Yeah.
In a very simple case.
Some kind of cylinder with something sticking out of it, I assume.
Yeah, it's going to be something like that with some holes to bolt it.
Yeah.
As far as I'm concerned, that's good enough. You might want to obviously put the output shaft because you're going to connect that up. There might be a built-in gearbox, but you don't need to worry about that. Don't worry about creating that.
Oh, by the way, do you know any like small scale motors that are designed to spin like very slowly?
That's why you have the little gearboxes put on the end, which Technobots do a range of gearboxes. So if you have a look at the combinations, you can get that speed down, and then if need be, you can add little pulleys and things or separate gears to get the speed down to what you want, almost precisely. Bear in mind that what will happen is things might not be exactly right, but they're going to be reasonably close. And you're going to build a prototype that's going to be reasonably close. Like, so I've given those 3 zones to launch into, and I haven't tightened those. Haven't tightened those up. They're quite open, so that gives you quite a range to land that ball in.
Yeah.
So that should work out fine. That should be okay.
Yeah, no, I was just worried that putting a gearbox in would take up too much space, especially horizontal space, since we only have 180 mils of that.
Yeah, but remember, you can position that any way you like. You can position it higher up.
Yeah, I guess.
I
mean, that's still 300 mils, so it's not really a large thing.
I don't want to be any more prescriptive. I mean, it's
I know.
We know that it's within a reasonable envelope. So I would probably keep a more positive mindset and then create your drawing. If there are, and there will be certain things which you might need to reflect on, but that's all part of the learning process. This is your first attempt. as a whole cohort, you would come a long way in a relatively short space in time, and we're not expecting perfection. I'm not even sure perfection exists. So it's about getting to grips with various aspects of engineering, sort of enjoying creating something of your own design, creating the parts, getting them made, putting them all together, having a bit of fun firing them into the zones, and let's see where we are.
Yeah. Okay. Yeah. I guess other questions in due course. Can you pass this on to Oliver, please?
Well, Oliver, I can see Oliver's got their hand up. So, all right, thank you for your question, Michael. I'm sure it'll be useful to everyone. So I'm now going to ask Oliver Jones. Would you like to ask your question?
Hi, yeah, I just had a quick question about the no glue rule for this.
Okay.
So with if we're using, for instance, PVC pipes in our design, are we allowed to use adhesives to attach those together as they're sort of designed to be done, or do we have to find mechanical fastenings for that?
I think the exception to the rule might be the PVC pipes, actually. What we're asserting as a general rule is that in every case, consider a mechanical fastening. And in 99% of the cases, there will be, nuts and bolts and rivets and things that you can use to put things together. But there will be situations where glue is probably more appropriate. But that's if you can't find a connecting angle for your tubes, because it's not water. We're not asking you to create a pump and a pipe system. So have a look to see if there is a connector, if that's what is appropriate for your design. And if there is a connector, then we would expect you to use it. But if you're cutting tubes at funny angles and you want to create something which is really very bespoke and individual, then what I would do is specify the glue. Please email David Wood, copy me in, to let him know and check the glue that you're requiring. Because that's the other thing. We want to make sure that we can source everything for you without any delays. If that makes sense, Oliver.
Yes, that does. Thank you. So with like PVC elbow joints, do the pipes stay in sufficiently without glue then? Is that just for watertight purposes that you need glue?
Yeah, usually the connectors are, if you look, I don't know how much these days the suppliers will give away, but what I would do then, I'm just thinking of where we are in terms of the timeline, is if there's a connector, I would specify that and make sure that we get that ordered. I would then, this is going to be belt and braces, but I think it's okay. You can then email Dave Wood, like I say, copy me in, ask him just to check the appropriate glue stroke solvent that will be used in the event that this isn't a good fit. But normally they're designed such that there is a sort of frictional fit to the pipes anyway.
Okay, thank you. Brilliant.
Right.
And sorry, one more thing. With the 3D model of the assembly, I know you said with motors we can do simplified representation like that. Can we do that with gears as well, or do we have to properly model the gears?
You can do that with gears as well. I don't mind if they're discs. That's perfectly acceptable. And you would probably draw them at the pitch circle diameter.
Okay, brilliant. Thank you.
That's good. Thank you for that, Oliver. Right, next we have is Aaron Lopez.
Yeah, hi. I don't know if this has already been answered in a previous lecture, but I just got a question about whether or not we're allowed to bore out the shaft diameters of gears. Because I was looking at Technobolt, and like the electric motor that I'd want to use, its shaft diameter is bigger than the gear that I'd want to use. So are we allowed to bore out that the gear inner diameter so that it can fit that shaft, or is that like not advisable?
That's perfectly okay. these are likely to be made out of nylon, the gears. So what I would do, so this might be, depends which one you're using, but let's just say the nominal sort of shaft diameters, let's take it as 4 mm. But if you've got a gear which has got a bore which is smaller, then it's absolutely no problem to make that that bore bigger. And then what you would do is please include that as a separate part drawing. And then you can specify on your drawing what your new diameter is going to be. That's diameter 6. Then you can create a drawing for that.
So would that be on our order form?
Right, so the gear would be on the Technobox order form.
Okay.
Or RS, wherever you're buying it from. You would then have a separate engineering drawing because you're actually going to change that part.
Right, okay.
What you're telling me is that you want to change that from a standard part to something that just suits your needs better.
Okay, perfect.
So just create a little drawing. What's quite nice is if students then put the part number of that gear on the drawing. You can just type that in so we know that that's the gear that you're going to modify. And then, of course, we make sure that operation doesn't get missed.
Okay. Mm-hmm. All right. Thank you.
Okay, so that's, and we have Daniel Thompson.
Yeah, hi. You mentioned previously when answering a different question that you were looking for the distribution of part drawings to be even across the team. And I've got a slight question with that in that my team has sort of like, we made designated roles for each member, and someone might be more in charge of the order spreadsheet or maybe the final report, and therefore their contribution to the part drawings wouldn't be as large. Would that be a problem in that some people would be predominantly focused on CAD, whereas others would have more be a treasurer role or some other role?
Okay, well, this is a really good point because what we do in this exercise is we sort of go for a sort of equitable distribution throughout. However, we know that there are areas where that won't work exactly. So as a group, you'll apportion roles. So I have no problem if you want to do that. But what I would like to see is that at least everyone does at least one part drawing. So it might be a very simple part that they draw. To then make it obvious to us that there has been this distribution. So let's say most other people, or it could be one other person, don't know how many parts we're likely to have, might be there's a dozen, 5 members do one member in particular then does the other 7. If you have a little table that says what the key roles are across the group, then that would help us just make sure that that's been done, that there is a sort of fair distribution.
Okay, brilliant. Thank you.
That's right. That can be a simple table. You could put that. You can put that in the introduction if you like. You know, you've got your specification, which might go into the introduction. It's just a very short sort of paragraph, maybe 2 of an introduction to the project, and then you can say, in order to achieve the aim, the group decided to assign roles throughout, and here they are in table 1. Then as you move on, you know, you've got the development of the PDS, and that effectively is then going to set the line of action for the group for the rest of the project. So I'm very happy for you to do that there and be upfront. We're not looking to catch people out. We're just trying to ensure that people do engage as a group.
Okay, great. Cheers.
Let me just have a look. I can't see I can't see any other questions, so but please raise your hand if you have a question you'd like to put to me.
There were two questions in the chat about CAD drawings.
Okay, Thomas, yeah, fire away.
One was, is the assembly drawing just a side view and plan view of the 3D drawing?
Yeah, no, with the views that you create, well, I say create, depending on how you do this. If you do this in Inventor or Fusion, those views will be created for you. So it's then a question of how much you want to show on your draft, on your actual drawing sheet. Now, it might be if you feel that the front view and end view, for example, shows everything that you need or everything that's sort of helpful in understanding your drawing, then you may decide only to put two views on. Now, as a standard rule, we tend to go for the front view, end view, and plan. But of course, you've got to manage the drawing sheet a little bit better to make sure that all sort of works. And then you can put on your dimensions. So that's the sort of general rule. If we see a drawing that only has two views, we'll just ask ourselves, you know, can we actually see all of it? Can we see the basic mechanisms and just understand the basic functionality of it? In which case you won't need one of the other views. Maybe you'll go for a front view and a plan view, and you won't need an end view. So there's not a hard and fast rule. It is up to the group to decide. But whatever decision you make, you know, bear in mind that people are going to be looking at this who are not familiar with it and need to just make a judgment that they understand the basic functionality. Do you have another question?
Yeah, there was one more regarding CAD as well. It was, do we need a 3D model of the whole assembly? Or is it fine to just draw the CAD parts that will be 3D printed?
No, the 3D model is of the whole assembly. This should be part of, I mean, if you're going down an Inventor or a Fusion route, then this will be something that you would do automatically anyway. You would create the 3D model and then you'd move on to your drawing sheets. So that wouldn't be any other work. But what we found in previous years that it's actually quite nice just to see the 3D model. And sometimes students show that in different angles. There are nice rendering functions in the software, so you can make that look quite nice, actually. I'm not saying realistic, it's not photorealistic, we're not asking for that, but it can be a very nice way of demonstrating to someone who's unfamiliar with your project so that they can see just the basic idea. Now, this is why right at the beginning, when I mentioned this year, you have been introduced to AutoCAD as well. And those 5 or 6 drawings that you did in semester 1, you know, those sort of 2D shapes, it could be that if you've gone down the Autodesk route, then you won't necessarily have this 3D model. In which case, you'll need someone in the group to create a sort of simplified, if you like, simplified 3D model of your basic design. And then you can submit that as a separate part. But I would have thought that all groups would have chosen Inventor or Fusion 360 to create this exercise. I mean, like I say, you can get around it if you're just going down the AutoCAD route. You can easily get around it, but that's what we would look for in the normal sort of process. Obviously, if you have any issues, just email me separately and we can work it through. That, you know, that shouldn't be a problem.
So sticking on the subject of CAD, that there was another question earlier, which was, do you need to CAD in, say, like bolts, for example? Do you need to add all of that to the assembly? And then off the back of that, someone asks, which parts do we need to CAD? Is it the whole, just the bespoke items?
Right, so the assembly drawing, here we, start with the 3D model, we would see everything. We would expect to see, certainly as far as you could go, you would have every part that's in there. Things like bolts, I think, are in the standard download catalog. So you wouldn't draw those, you would just download those, put a few dimensions in, and I think the system just puts those in for you. Now, if you wanted a very simplified, if for some reason there was an issue with doing that, you could just put a very simplified cylinder, a couple of cylinders or a hexagon and a cylinder, and just say that's your bolts. But you would show that somewhere on drawing, your very final drawing. Now, there are sort of levels to this. It might be that, if you get to that point and you feel that the time needs to be spent just doing other things, then it's not the end of the world if you do miss these bolts out, because the positions will all be shown, the key components will be shown, and clearly most of the work will be done. You'll have the part drawings so that when it comes to actually make the product, you'll have all the bits there and you'll have all the bolts available to you. So you'll be able to go ahead and make it. So don't worry of the knock-on effect, because I don't think that will hurt you at all. It's just in being upfront in showing all as much detail as you can in this drawing, which will then ultimately be generated in the assembly drawing. So there's nothing more for you to do. But if this isn't 100% complete, like I say, don't worry on Julie, because the bolts you'll specify in the order sheet. Any parts that need to be manufactured according to your own designs will be listed in the drawings. So when you come back next year, all the stuff will be there for you to still go ahead and make and assemble your product. It's just that for the top level 3D CAD drawing and assembly drawing, the basic rule is we would expect to see everything. Whether it be schematic or not, if it, like I say, if it's the motor, then that could be a cylinder with a plate. We're not expecting that to be a manufacturing drawing, but there is a drawing of it. So it's the same with the bolt. We're not expecting a manufacturing drawing, but at least there's a drawing of it. Hopefully that makes sense, Sam. Well, I suppose I should ask the students if that doesn't make sense, or if you want to ask a question for me to clarify something, then please go ahead. Don't be bashful on this.
Sorry, I was reading something else while you were explaining that, but did you answer the one about which parts do we need to CAD? Is it the whole thing or just the bespoke ones?
Yes, well, I think I went through that at length at the beginning, but I'll just make a clarificatory sentence. Yeah, so the 2D part drawings are only required for parts which are to your own design.
So that's just the drawings, but the assembly needs to include other things. Like if you use the motor, it should have the motor CAD, or at least a representation of the motor CAD if there's not one supplied by the manufacturer.
Yeah, it has to be represented somewhere, but that can be simplified.
Okay. If going back to the glue question, so I had something before, so this is a bit more specific. So for example, if someone wants to glue two laser cut parts together, is that okay?
No. So that would be not okay, because you can, as part of your laser cut design, you could have laser cut in some holes and you could have bolted those together.
Okay.
This is the reason why we don't want glue, because you can end up, I'm not devaluing the use of glue, and some of the glues that are available now are quite incredible. But what we're looking for is use of mechanical fastenings wherever possible, and it's really by exception that you would have a glue. But like I say, Loctite produce a range of glues now that are unbelievable in terms of what they can do, but that's not what we're asking students to get involved with in this exercise.
Okay, that's good. I suppose in the video I released yesterday, I said you could make a strong box by gluing it together, so I take that back completely. So hopefully I didn't cause any confusion there. Okay, there's another question, which is there a method to bend PVC pipes to desired angles?
I'm sure it can be done, but it wouldn't be done in this exercise. What you would, I mean, if you've got to angles, I mean, at the end of the day, you've got to be careful, because, you know, that ball's going to go in, and I often think simplicity is going to help you the most. So if it's a straight pipe, maybe with a connector,